The purpose of this lab is to model a ball which bounces on a surface. The model, using some estimations, will give us a contact force between the ground and the ball. We will be using both F equals ma to track the initial movement of the ball due to gravity, and F delta t equals m delta v, the momentum equation, to find the contact force. I took this video from online, so I calibrated it to the guy's height, which I estimated to be 6 feet because I can't entirely be sure. The y-axis points up and the x-axis points right. The origin is close to where the ball lands. Now let's watch the video. I calculated V initial using the program, as I'll show you later, but I had to use estimation and 2 points to calculate V final, both of which I have to use for impulse because m delta v requires V final and V initial. So right after the ball bounces, I took 2 points and found V final. I also had to estimate delta t, the time in which the ball was on the ground, because Tracker doesn't have enough frames. I estimated it to be around 0.41 seconds. These are both possible errors that could have led to a contact force miscalculation later on in the program. So now let's actually look at the program itself. So here's the program. The ball mass is around 1 kilogram. I set the ball position to the initial position from where it falls from the person's hand, and I set ball.vel to the initial calculation of velocity I used from the 2 points, from the second it leaves his hand to the next frame. So I got V initial from there. And then down here I set delta t to 0.001, which is a really small time. And now we'll move down, and now you'll see that I made multiple while loops. This is because the first one is while the ball is falling, where fnat equals negative 9.8, because g equals negative 9.8. Then the second while loop is just to advance time, because the ball doesn't actually move in that 0.41 seconds, which is my estimation. And then the final while loop is when the ball bounces in the other direction. For this, I had to use 2 points to calculate the second ball.vel. I called it ball.nel, and that's vector negative 0.018, 4.2, and 0. So we'll go down here, and at the bottom of this, ball.gel is what I called the final velocity of the system of the ball, and I calculated contact force as ball.m times ball.gel minus ball.m times ball.vel, so that the mass of the ball times V final minus the mass of the ball times V initial, and all of that is over the time, which I estimated, so 0.041, and that shall give me the contact force using impulse. That's the impulse equation I use. So now let's run the module. You'll notice that the ball drops from his hand, speeds up, and bounces back, right as actually happened in the video. Now we'll look at the actual contact force. We will notice that the contact force is in the y direction is 243 newtons, which is quite a bit, but given the tiny amount of time that the ball actually comes in contact with a surface, it makes sense. So possible errors in the experiment include the estimation errors, and also that the ball can also move backwards in the z direction. On top of that, it's simply impossible for me to actually tell using Tracker the exact delta t timing. So if delta t is incorrect, then the contact force that I calculated will also be incorrect. So that's it. I hope you enjoyed. Thank you.